Today let's talk about classifying polygons. Polygons are stuff you talked about in middle school. We're just going to remind you what they are, how to classify them, and what to do with them. We take this objective, we will identify polygons by their properties using class discussion and notes. Vocabulary: polygon is a closed 2D figure that has at least 3 sides and angles. Convex, a polygon that has all interior angles less than 180 degrees. Concave, a polygon that has at least one angle more than 180 degrees. More vocabulary: equilateral, equiangular, regular polygon, triangle, quadrilateral. These are all vocab words we are going to get into as we go further into the lesson. These are more vocabulary words. More. Now, what is a polygon? Like we said, polygon is a closed figure that has at least 3 straight sides and angles. So notice that these are all closed. They are all straight lines. What's the difference between concave and convex? Let's look over here and then look over here. What do I notice? Convex, concave, convex, concave. Now, notice how I can draw a person inside here. He's standing inside the figure. Over here, he has some shade from the figure, right? If this was a cave, if this was a cave, and another cave, hence the word concave. Now, the true definition is, if I look at this, all the angles are going to be less than this. What is that angle? This is 180 degrees. So this one is less than 180. But if you notice, this angle is more than 180 degrees. So when I say that a convex polygon is a polygon that has all interior angles less than 180 degrees, these are less than a straight line. But then when I go to concave and I see a polygon that has at least one interior angle greater than 180 degrees, I know that I have an angle that is bigger than a straight line. Are these polygons concave, convex? That is a, whoops, he has me a cave. That is a concave polygon. Here, is this a polygon at all? I think not. This is actually a circle. Remember, polygon has straight line segments. Here I have a concave polygon. Here I have a convex polygon. Here I do not have a polygon at all because it is not closed. This is a concave polygon. Now, equilateral, like we said in the previous unit, was a polygon that has all 3 sides, or I'm sorry, all sides congruent. Equiangular, when all the angles are congruent. A polygon that has all angles congruent. Regular polygon is when I have both all the sides the same and both all the angles the same. I get a polygon that is both equilateral and equiangular. Watch what happens when I combine them. 1 plus 1 is 2. So that is a combination of equiangular and equilateral. Now, triangle, that is a figure with 3 sides. Quadrilateral, that is a polygon with 4 sides. Pentagon, this is a polygon with 5 sides. Well, it's not showing up, but you know it's 5. This is hexagon, looks like this. How many sides do I have? 1, 2, 3. Head, 4, 5, 6. So this is 6. Heptagon. Heptagon looks like this. It's a figure with 1, 2, 3, 4, 5, 6, 7. Octagon, October, octave, octuplets. That's 8 babies, 8 sides to a polygon. Nonagon, 9 sides. Decagon, 10 sides. Hendecagon, 11 sides. Dodecagon, 12 sides. Now watch what happens. As I increase the number of sides to a polygon, you notice that the polygons start to go more towards a circle. Now watch what happens. If I had a small amount of polygons and I start to add more polygons and more polygons, you notice that the figures start to look smoother. The image of this person starts to look smoother. In video games, we started off back in the day in the 90s with N64. See how he's all blocky? And then as I slowly increase the amount of polygons in my image, they start to look more real until they look almost perfectly real. That's all. There's a lot of vocabulary, so make sure you study your vocabulary every single day.